Hello friends, in this video we shall discuss with respect to the solution video of MHSET Maharashtra SET eligibility test which was conducted on 15th June 2025. We are going to discuss paper 2 electronic science paper. The question paper consisted of 100 question which was asked for 200 marks. To keep the video very much short, we are going to cover from question number 1 to question number 25. Let us move on to the first question. In the first question, what they have given is, in the semiconductors, what is the role of doping? The first option what they have given is, it increases the band gap of the semiconductor material. It introduces the impurities to modify the electrical properties of the material. It enhances the thermal conductivity. It decreases the resistivity of the semiconductor material. In the case of semiconductor, when you are going to add doping, why you are going to add doping means you want to increase the conductivity. Nothing but you are going to modify the electrical properties. You are going to decrease the band gap. So the first option will be the wrong one. The suitable option that is going to follow is option B, nothing but it introduces the impurities to modify the electrical properties such that band gap you are going to vary and then each and everything will be carried out. So for this, the suitable option that is going to follow is option B. In the second question, what they are given is, in a semiconductor manufacturing, what does the term wafer refers to? See, in the CMOS VLSI lecture, in the fabrication part, what I told, take a wafer of some diameter. In that, you are going to realize a transistor. So, it is a thin slice of a single crystal semiconductor material. This option is correct. You're going to take a silicon, you want to go for a doping, you can go for a doping, or later stage you want to go for a doping, you can go for a doping. You're going to take a die. You are going to take a die or you are going to take a unit area. In that you are going to make a partitions and then you are going to realize a transistor. So wafer is a thin slice of a single crystal semiconductor material. The corresponding option that's going to follow is option A is correct. In the second option, what they have given is the metallic layer on top of a semiconductor device. They have given it is wrong. The insulation material between different semiconductor layers, it is wrong. You are going to make use of thick oxide or thin oxide layers. The encapsulation material used in semiconductor packaging. No, this option is also wrong. So the suitable option for the second one, it is A option. For the third question, what they are given is, in a Zener diode, what is the primary role of the depletion region? To increase the forward bias current, to provide mechanical support to the diode, to enhance the reverse breakdown voltage, to reduce the capacitance of the diode they are given. The primary role of the depletion region is to enhance the reverse braking voltage if you are operating in a reverse bias. Zener diode, when operating in a forward bias, it is similar to a normal diode only. There is no concept of mechanical support, all those things. To reduce the capacitance is also wrong option. So for this, the suitable option that is going to follow is option C, nothing but to enhance the reverse breakdown voltage. Let us move on to the fourth question. What they are given is, the chemical used for shielding the active areas to achieve selective oxide growth is silver nitride, silicon nitride, hydrofluoric acid, polysilicon. Definitely it will not be a polysilicon. It is a silicon nitride. So the corresponding option that's going to follow is option B is correct. In the fifth question, what they have given is, they are asking with respect to the scaling factor. The scaling factor for current density. Current density is given by I divided by A. See, that too they are not asking general scaling, they are asking constant voltage scaling. In the case of constant voltage scaling, wherever you are having the voltage parameter, you are not going to scale that parameter. Nothing but you are going to take beta equals to 1 and then you are going to solve. Now look at the things. Current, you are going to write it as a mu n times of Cox into W by L into. Let us assume we are going to operate the transistor in saturation region. In the case of saturation region, it is a VGS minus VTH the whole square whole divided by 2. Look at the things carefully. This VGS minus VTH, it is also referred as overdrive voltage divided by area. Area you can take it as a length into width. Now look at the things. Are you going to scale mu n? No. Cox? No. Cox you are going to take epsilon ox by Tox. The Tox you are going to scale by 1 by beta. And this VGS minus VTH, nothing but it is a voltage term. So the voltage term is scaled by beta, right? So here you will be getting 1 by beta square. Here you will be getting 1 by beta in the case of Cox. So the overall scaling parameter in the case of current will be 1 divided by beta. But look at the things. Length is scaled by 1 by alpha. Width is scaled by 1 by alpha. Sending to the numerator, what I am going to get, alpha square divided by beta. This is in the case of general scaling. But they are asking in the case of constant voltage scaling, take a beta equals to 1. So what you are going to get? Alpha square. What you are going to get? Alpha square. This W by L is referred as aspect ratio. W is scaled by alpha. Length is also scaled by alpha. So the term will get cancelled. So for this, the suitable option that is going to follow is option C is correct. Nothing but the current density of in the case of constant voltage model, it is scaled by alpha square. What is the primary block in the case of FPGA? In the case of FPGA, the primary block will be lookup table. So the primary block will be lookup table. So for this, the corresponding option that's going to follow is option C is correct. So friends, till now, if you are not liked the video, please give it a big thumbs up. In the 7th question, what they have given is, they have given a 4-bit ripple counter. How many clock pulses are required for a complete counting cycle they have given? So, in the case of 4-bit ripple counter, so for the complete cycle, you are going to make use of 16 cycles. You are going to make use of 16 cycles. For this, the corresponding option that's going to follow is option C is correct. Nothing but 2 power 4 will be 16. So maximum cycles will be 16, then it is repeated. The pattern will be repeated. Dash is used to carry digital data on analog lines. See, we know that modem. Modem stands for modulator and demodulator is the correct option. Demodulator, modulator is used in communication. Multiplexer is a combinational circuit. Right? So many to one, nothing but 2 power n inputs will be having, only one output you will be there, you will be having, and which input should be driven to the output, it is based on the select lines. So for this, the corresponding option that is going to follow is option A is correct. For the 8th question, the corresponding option that's going to follow is option A is correct, nothing but a modulator and a demodulator, modem. For the 9th question, what they have given is modulo 6 counter can be built with the help of dash flip-flops. Modulo 6 means what? It can able to count 6 possible states. So with the help of 2 flip-flops, if I am making use, maximum how many states you can count? Only 4 states you can count. Right? Let us assume 0, 0, 0, 1, 1, 0, 1, 1. This is the maximum states what you can able to count. But if I am making use of 3 flip-flops, how many states I can count is, I can count 8 states. I can count maximum 8 states. More than 4 I can able to achieve. But here what they are given is modulo 6, nothing but 6 possible states can be realized with the help of 3 flip-flops. For the 9th question, the corresponding option that is going to follow is option B. Nothing but 3 flip-flops are enough. In the 10th question, what they are given is, what does the term poles and zero cancellation is going to imply? It results in an unstable system. This option is a wrong option. It improves the transient response of the system. It is wrong. It simplifies the transfer function of the system. It reduces the order of the system. Reducing the order of the system, if you want to do, you are going to add zeros to it. At that time, the order will get reduced. So for this, the corresponding option that is going to follow is option C is correct. Nothing but, say suppose the system is tending to become an unstable. If you want to make it stable system, you are going to add zeros to it. Your system response is not good, you try to add pole to it, such that pole zero cancellation is going to take place, but the system performance is going to get improved. For this, the corresponding option that is going to follow is option C is correct. For the 11th question, what they have given is, in the case of FSM diagram, what does that circle indicates? Finite state machine, what does that circle indicates? It is going to indicate the state. It is going to indicate the state. In the 12th question, what they have given is a dash are employed to specify parameters that can be supplied to VHDL entities. It is generics. It is generics. The corresponding option that is going to follow is option D is correct. In the case of 13th question, what they are given is a dash is an example of a combinational circuit. In the case of shift registers, you are going to make use of clock. So it is a sequential circuits. Counters, you are going to perform up counting, down counting, nothing but it is operated with the help of clocks only, and you are going to make use of flip-flops. So it is a sequential circuits. Flip-flop is a bistable element. It is a sequential circuits. So multiplexer is a combination circuits which will be having 2 power n inputs, but it will be having only one output. It will be driven with the help of n select lines. So multiplexer is a combinational circuits. For the 13th question, corresponding option that's going to follow is option D is correct. Look at the things. What is the purpose of inverting and non-inverting input terminals of an operational amplifier? Determine op-amp's power supply, no. Control gain of op-amp, it is also wrong. Define the amount of feedback, no. It is used to provide input signals for differential amplification. This option is correct. So for this, the corresponding option that's going to follow is option D is correct. 15th question, which of the following design styles provides higher integration density? Switch transistor logic, transistor buffer logic, transistor logic, circuit level logic. So if you want for higher integration, you can go for, transistor logic. In short, it is also referred as TTL logic. So for the 15th question, corresponding option that's going to follow is option C is correct. In the case of 16th question, already we have discussed in CMOS VLSI, we are going to make use of lambda based design rules. For metal 1, minimum width you have to maintain is 3 lambda. For metal 2, it should be 4 lambda. For depletion and for this polysilicon 2 lambda you have to maintain. So that lambda based design rules is going to fix up on the minimum side. So for the 16th question, option A is going to follow. For the 17th question, which of the following is used to obtain a silicon single crystal structure while fabricating and in an integrating circuits? So oxidation, epitaxial growth, photolithography, silicon wafer preparation. So for this, the corresponding option that's going to follow is option B is correct. Epitaxial growth, right? So you are going to create an oxide layer. You're going to create an oxide layer. In this epitaxial layer, where you're going to use, you please comment in the comment section. One hint I can give you, that is in the case of Quinta process, you're going to make use of this epitaxial layers. In the 18th question, the pull up to pull down network, what should be the ratio of the pull up network to pull down network? It should be 4:1. So only the overall delay, the total delay, in the case of NMOS pair delay, you are going to get a 5 tau. That will be 4 tau plus tau, or 1 tau plus 4 tau. That will be 5 tau you are going to get. In the case of CMOS delay, it will be 5 tau plus 2 tau, or 2 tau plus 5 tau, 7 tau. Right? So NMOS inverter pair delay, you will be having a delay as less when compared to CMOS. In the case of NMOS, delay will be 5 tau, and in the case of CMOS, delay will be 7 tau. For the 18th question, option B is going to follow. For the 19th question, what is the purpose of Norton's theorem? See, in this, the key answer what they are given is the simplify parallel circuit. It is not to simplify only the parallel circuit, give any circuit of your choice. So it can able to convert to a single current source, call it as a Norton current. In parallel to it, you are going to connect one Norton's impedance, and across to it nothing but in parallel to it you will be having a load. See, you will be having a Norton source, and you will be having a Norton's impedance. This Norton's impedance, it can be a resistance, or it can be even impedance also. So at last what you will be doing is you will be connecting a load. See, Norton's is just a dual of which one? Thevenin's theorem. So, it is used to calculate equivalent resistance. Option C should be the correct answer. 19th question, Norton's equivalent circuit is in a parallel with it is in parallel with a resistor they have given. It is not only resistor, it is an impedance, right? It can be a capacitive network, or it can be a resistive network, or it can be an inductor network, or the combination of RL, RC, LC, RLC. It can be any of the things, right? So the key answer they have given it as a resistor. If they would have given an impedance, then I would have opted for impedance. For the 20th, option A is going to follow. The Laplace transform of a unit impulse transfer is, they are given it as 1. Strictly speaking, it should be 1, but the key answer what they are given is the Laplace transform of impulse function they are given. Impulse function means what? How you are going to represent delta of t. That representation they are giving, that's it. That representation they are giving, that's it. So, what is the transfer of this del of t? 1. What is the transfer of u of t? It is 1 by s. What is the transfer of Laplace transform of r of t? 1 by s square. What is the Laplace transform of parabolic? It is 2 divided by s cube. These things you should know. Important, carefully you please go through it. 22nd question. In filter design, what is the purpose of Butterworth filter or Butterworth approximation? In the case of Butterworth filter, you will not be having any ripples in a pass band or any ripples in a stop band. But in the case of Chebyshev filter, you will be having ripples either in a pass band or in stop band. So, the main purpose in the case of Butterworth filter is to minimize this ripple, and to achieve a flat response. So, based on this explanation, the corresponding option that is going to follow is option A is correct. Nothing but to achieve maximally flat response in the case of both pass band and stop band. So, for this, the corresponding option that is going to follow is option A is correct. What is the disadvantage if you are going for a Butterworth filter? What is the advantage and disadvantage if you are going for Chebyshev filter? I have made a detailed comparison of this. Go through my lectures. I have explained the things in a proper way. The phase difference between the input and output voltage in the case of common base arrangement will be, see, in the case of common emitter configuration, the phase with respect to voltage will be 180 degree. In the case of common base configuration and in the case of common collector configuration, we say it is a unity gain. So, gain will be equals to 1, not equals to 1, but it is approximately equals to 1. In the case of common base configuration and in the case of common collector configuration also, the phase will be 0 only. If I am talking about arrange in decreasing order, which one gain will be more? Common base gain will be more when compared to common emitter configuration, when compared to common collector configuration. Important. Right? Most of the persons will be assuming that the common emitter gain will be more than common base. No, common base gain will be more. How? In the case of this small signal analysis, we have studied it is GM times of RL. In the case of a common emitter configuration, it is a minus GM into R0 in parallel with RL. That's it. R0 term will be there, parallel will be reduced only. So, for this, the phase difference between the input and output voltage in the case of common base configuration will be equals to 0 degree. 24th question, which of the following is true about the FET as its advantages? It will be having a low input resistance, it seems. No. It is having high output resistance, it seems. No. Resistance here you can take it as impedance also. Big size, small life. No. It will be having better thermal stability. This option is correct. If they would have given a high input impedance or low output impedance, then you can opt for it. So, For the 24th question, it will be having better thermal stability. Nothing but as temperature increases, it will not be having an effect on leakage currents. Leakage currents will be suppressed. See, we know that the solar cell will be operating in the third quadrant. And the photo cell will be operating in, or photodiode will be operating in fourth quadrant. Now look at the things. This is VOC and this is ISC. Now what they have given is take this current as VX IX. This is the region what you will be getting. VOC and ISC, it is at the time of charging. But what it will be giving out is a VX and IX. In the IV curve of a solar cell, what does the open circuit voltage VOC represents? It is nothing but the current equals to 0. At that point you are going to get VOC. Nothing but the voltage when the current is 0. The voltage when current is 0. For this, the corresponding option that's going to follow is option C is correct. So friends, so far we have discussed from question number 1 to question number 25. In the next part of the video, we shall discuss from question number 26 to question number 50. I hope the solution video will be very much helpful for you and it is understandable. If you are following with the solution lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.